Sliding surface bearings are often divided into two basic categories based on the type of load that specific bearings are generally designed to handle. The two categories are journal bearings and thrust bearings. Journal bearings are generally designed to handle radial load, and thrust bearings are generally designed to handle axial load. Let's look at journal bearings first. A journal bearing is the simplest type of bearing because it has just one part, the bearing itself. The bearing is the cylindrical part that surrounds and supports the shaft. The term journal does not refer to a part of the bearing. The journal is the place on the shaft that is surrounded and supported by the bearing. Two basic types of journal bearings are solid bearings and split bearings. Here are two examples of solid journal bearings. A solid journal bearing is sometimes called a bushing or a sleeve bearing, depending on its thickness. A bushing is a solid cylinder of relatively thin metal that receives most of its strength from the housing in which it is mounted. The term sleeve bearing usually refers to a thick-walled type of solid journal bearing. This is an example of a split journal bearing. This bearing is bonded to its housing. The bearing and the housing can be split into halves, so it is relatively easy to remove them from the shaft to examine or repair them. Journal bearings are generally designed to handle radial loads, and thrust bearings are designed primarily to handle axial or thrust loads. Thrust bearings are generally used in pairs. One bearing is placed on either side of a thrust collar. The thrust collar is a solid metal disc that may be a separate part attached to the shaft or an integral part of the shaft. The two thrust bearings support axial load in both directions on the shaft. We'll look at two general types of thrust bearings: flat land bearings and tilting pad bearings. This flat land bearing is one of the simplest types of thrust bearings. It is a solid piece with no movable parts. Grooves in the bearing divide it into sections called lands. This bearing is a tilting pad thrust bearing. It's also called a Kingsbury thrust bearing. A typical tilting pad bearing has two main parts: movable thrust shoes and a support bracket. The thrust shoes are pivoted to allow them to move slightly. The thrust shoes rest on the support bracket. They're held in place by pins on the support bracket that fit into holes on the back of the thrust shoes. The material that is most commonly used to make sliding surface bearings is Babbitt. Babbitt is an alloy made of three metals: tin, antimony, and copper. The actual amount of each metal that is put into the material varies according to the way that the bearing is to be used. Babbitt is relatively soft, so it is always bonded to a shell that is made of a stronger metal, such as iron or steel, if it is intended to support a heavy load. Babbitt is a very useful bearing material because it has all of the properties that a bearing material should have. Two other metal alloys that are commonly used to make bearings are bronze and brass. Bronze is made of copper and tin, and brass is made of copper and zinc. Bearings can also be made of non-metallic materials. For instance, this bearing is made of a type of plastic called phenolic. A major function of bearings is to reduce friction. Friction is the resistance to motion that occurs whenever one surface moves over another. In sliding surface bearings, friction is reduced by a process called film lubrication. Film lubrication is a process in which a film of lubricant is distributed and maintained between the bearing and the shaft as the shaft rotates. Lubricant stored in the bearing housing is picked up by the spinning shaft and pulled between the surfaces of the bearing and the shaft, where it forms a film. As the shaft rotates, it floats on this film of lubricant, so there is no metal-to-metal contact between the shaft and the bearing. If the film of lubricant were not present, the shaft and the bearing would contact each other and wear out rapidly. The film of lubricant also increases the amount of load that the bearing is able to support because it distributes the load over a greater area of the bearing surface. Sliding surface bearings are usually lubricated with oil. One common oil lubrication system is an oil ring system. In this system, a ring rests directly on the shaft. The lower half of the ring is submerged in oil in a reservoir located in the lower half of the bearing housing. As the shaft rotates, the oil ring turns, carrying oil from the reservoir up to the top of the shaft. The oil spreads across the shaft, and any excess runs back down into the reservoir. In a piece of operating equipment, as the shaft continues to turn, a continuous film of lubricant forms between the bearing and the shaft. Another type of oil lubrication system for sliding surface bearings is a force feed system. This type of lubrication system is used when a pressurized feed to the bearing is required or when it is necessary to keep the oil filtered and cool. In a typical force feed system, oil is stored in a reservoir that is separate from the bearing. A pump forces the oil into the bearing. After the oil has passed through the bearing, it is collected in the reservoir so that it can be pumped again. Oil filters are often used in force feed systems to keep the oil clean. Filters remove dirt from the circulating oil. Many force feed lubrication systems also use oil coolers. Coolers remove heat that the oil picks up from the bearing. Grease is occasionally used to lubricate some sliding surface bearings. When grease is used, it is generally pumped into the bearing with a grease gun. The grease is pumped through a grease fitting located on the housing. Check your plant's procedures to see how often bearings should be greased and how much grease to use. In any case, it is important to keep the lubricant free of contaminants and to make sure that the lubricant stays in the bearing. Most sliding surface bearings use shaft seals to keep the lubricant in the bearing and dirt and grit out. Two common types of shaft seals are contact seals and labyrinth seals. Contact seals are generally fixed to the bearing housing. They rub against the shaft as it rotates. Contact seals are made of soft materials, such as rubber or felt, so that they will not damage the shaft. Labyrinth seals are usually made of metal. A labyrinth seal comes in two parts. One part is attached to the shaft and rotates with it. The rotating part fits into a fixed part that is attached to the bearing housing. The two rings that make up the seal are ridged. The ridges force any leakage to follow a long bending path that prevents oil from leaking out and outside contaminants from getting into the bearing.